A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hi. The first atomic bomb was dropped on Hiroshima at 8:15 a.m. on 6th August 1945. The use of nuclear weapons was the last resort of the United States found to defeat Japan during the World War II. The bomb's name was Little Boy. The bomb was made of uranium-235 isotope coated with lead and had a strike capacity of 12,500 tons of TNT. Hiroshima was engulfed with flames rising like the sun. The mountainous smokes rose into a height of 40,000 feet in the shape of a mushroom. The dust swelled up to a height of 1,000 feet. About 1.5 million people disappeared in an instant. 37,000 people were severely burnt by the nuclear radiation. More than 4 million survivors and their descendants were stricken with cancer and died later. Another plutonium-238 bomb named Fat Man was dropped on Nagasaki on 9th August 1945. These attacks shocked and hurt not only Japan but the whole world. The pain and sufferings of the survivors was indescribable. The former death toll of the city had risen to 14 lakhs by the end of this year. Diseases such as cancer caused by nuclear proliferation continues to kill people for decades. Nuclear atomic bombs have such a destructive power to destroy a country. How was it possible to produce such an extremely devastating energy from atomic bombs? Will it be possible to use this energy for peaceful purposes? The principle behind atomic bombs is nuclear fission. Nuclear fission is the process by which the nuclei of greater mass are split into lighter nuclei using neutrons. Let's see how a uranium-235 nucleus undergoes a nuclear fission reaction. Here, a slow neutron bombards the heavy uranium-235 nucleus first. The uranium nucleus undergoes disintegration. Two smaller unstable nuclei are formed. Fast neutrons separate from these dissociated nuclei. The mass of the small nuclei formed is less than that of the parent nucleus. It means that there is a loss of matter during such a splitting. The matter that is lost is converted into energy. According to Einstein's equation, E is equal to mc square. Even if the matter converted is very small, the energy produced will be very large. E is equal to mc square is the equation for the energy E released when a matter of mass m is converted into energy. C is the velocity of light. How can we calculate how much energy is produced when 1 kilogram of matter is converted into energy? E is equal to 1 into 3 into 10 raised to 8 the whole square, which is equal to 9 into 10 power 16 joules. This is such a huge amount of energy. If it is completely converted into electrical energy, we will get about 2,500 crores unit. This is the equation which gives the information about changing matter into energy that made Albert Einstein world famous. Uncontrolled fission will release a huge amount of energy. In 1 millionth of a second, a large amount of energy can be released. This causes a large amount of heat to the generator and it will end up in a huge explosion. There is also another nuclear reaction which is nuclear fusion. Nuclear fusion is the process in which lighter nuclei are combined to form heavier ones. In this process also, the matter lost is converted into energy. The energy is produced in stars in this way. This principle is used for making a hydrogen bomb. The scientific world has not yet been able to produce energy commercially by controlled nuclear fusion. On the other hand, there are power stations to control fission reactions and produce electricity. They are known as nuclear power stations. A nuclear reactor is a system that converts nuclear energy into electrical energy. Enriched uranium is the fuel used in nuclear reactors. Using nuclear energy, water is converted to heme at a high temperature and pressure. The force of the steam is used to turn the turbines to generate electrical energy. Such power stations are established at Tarapur, Kalpakkam, Kota and Kudankulam. Here, the nuclear energy is converting into heat energy, then to mechanical energy and finally to electrical energy. Dangerous radioactive radiations and products are also formed in nuclear reactors. The pollution caused by the presence of radioactive substances and radiation in water, air and environment is known as nuclear pollution. The nuclear decomposition of polluted materials results in a dangerous pollution. As a result of nuclear decomposition, alpha and beta particles and gamma radiations spread out. The probability of danger is determined by the factors including the density of polluting substance, the type of radiation, the proximity of pollution to physical organs. Nuclear hazards can be artificial or natural. Cosmic rays from outer space and the radiations from radioactive materials on the earth are examples of natural nuclear hazards. The use of radioactive isotopes in the medical field and the waste from nuclear reactors are examples of man-made nuclear hazards. So, what are the precautions to face nuclear hazards? Shift out immediately to safer places such as concrete buildings and buildings constructed using bricks. Strictly follow the directions from the concerned authorities. Observe the symbols showing the nuclear radiations and behave accordingly. This symbol shows the warning against nuclear reaction. Reduce the density of population in places likely to experience nuclear hazards. If necessary, consume potassium iodide tablets or take food rich in iodine. So, in this session, we have learned the properties and importance of nuclear energy. Nuclear energy has its own bright side and dark sides. Every invention achieves its greatness when it is used for the progress of our society. Nuclear energy should be used to overcome the energy crisis, not for building bombs and spreading hatred. See you later.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ എൻക്ലാപ്സ് ദ ലേണിംഗ് ആപ്പ്.